about lift induced drag calculation. So this is the main parameter in the drag calculation, drag power calculation. So we must understand how the lift is during the takeoff and the landing. This drag is induced by operating on various control surfaces. So let us take an airplane profile from the wing. So it is induced of some angle from the fuselage reference axis. So let us take this angle as induced angle of attack. So I induced. So the total overall angle of attack is angle between the chord line of the airfoil to the free stream velocity. Let us take the free stream velocity made to the peak is coming in this direction of angle of attack alpha. So this is induced angle, this is the angle of attack, this is effective angle of attack. So this is the effective. So we have got three things. What is? So induced or geometric angle of attack. So second one is E effective. This is the effectiveness of the aerofoil with respect to the free stream velocity mean. So this is effective angle of attack, and this is angle of attack, overlap angle of attack with respect to the airfoil position. So now we need to calculate with respect to this induced angle. So here we have the center of pressure and we have the resultant lift value with respect to this same. So we have here also we have the alpha. So we will get the lift equation in terms of lift. This is the resultant lift. So we have the resultant force of the resultant drag. This drag is induced drag. So this is dI is induced drag. So we need to calculate this dI with respect to the alpha, the position of the wing in incident angle. So this drag. Before that, we have to understand that the effective angle of attack alpha effective is equal to the angle of attack minus incident angle. Right? So coming to the drag equation, induced drag equation dI. So here we need to find out this resonant component with respect to the resultant vector L. So we got L sin alpha I. So generally we know the formula for lift equation is of rho v infinity square S into lift coefficient CL. Similarly for drag equation of rho v infinity square S CD coefficient of drag. So for induced drag, CDI is equal to of rho v infinity square S in surface, that is in surface CDI. So replacing this lift equation and the drag induced drag equation to the induced drag calculation. So we are let us take this as equation number 1 and this is equation number 2. Right? And this all we are going to replace in terms of force as in terms of lift coefficient and drag coefficient. So this is our equation number 2. Consider this alpha I is very small in terms of, so let us say sin alpha I is very smaller is equal to angle. So let us take sin alpha I as all the lift, drag and induced drag forces in terms of coefficient. Let us replace with this dI product of rho infinity square SW CDI is equal to of rho infinity square SW CL into alpha I. So now we are cancelling the all of rho v infinity square SW of rho v infinity. So we are getting CDI is equal to coefficient of drag, induced drag coefficient is equal to coefficient of lift into alpha. So this equation helps to get the airplane performance. Basically, the drag produced due to incident drag or induced case. So now we are going to calculate what is alpha. This we need to understand from the aspect ratio or profile of the wing. So now we are going to find alpha I, that is the induced angle. So let us say now we are taking the wing which is having different aspect ratio. That is aspect ratio is V square by S. So how the wing span length is respect to the wing surface area. Let us take this wing, elliptical wing lift distribution. The lift distribution in the form of elliptical. So this induced drag and alpha I is purely depends upon how this wing tip to tip, that is wing span, wing surface area is helps to produce a lift. So that alpha I is directly proportional to lift coefficient to the elliptical wing distribution based on the aspect ratio, and that is this E is span efficiency factor. So all we call it as Oswald efficiency factor. Oswald efficiency factor. So mostly for elliptical distribution cases, E will be the ratio E value will be 1. For other type of wing cases, E will be 0.85 to 0.95. This is the value. This means for any elliptical wing condition, it is 100% efficiency. That is 100% efficiency produced by the wing surface. Whereas other wing condition, whereas aspect ratio is different condition, E will be that is 85% to 90% of efficiency. So now we got the alpha is equal to coefficient of lift produced by the wing entire wing surface with respect to the what is the pi is 3.14, and this is here as aspect ratio, and this is also efficiency. Now we are substituting this equation number 5, equation number substituting equation number 5 in 4. So we will get coefficient of induced drag is equal to CL into replacing this alpha is equal to CL by aspect ratio into Oswald efficiency. We are getting CL squared by aspect ratio into E. That is lift induced drag coefficient in terms of lift coefficient and aspect ratio and Oswald efficiency. From this, we are getting inference. Coefficient of induced drag is equal to CL squared by aspect ratio into Oswald efficiency. It says that coefficient of induced drag is directly proportional to lift coefficient square, and one more thing is this coefficient of induced drag is indirectly proportional to aspect ratio. These two values help us to design the aircraft or airplane in terms of better performance. It means that if the induced drag is high, then lift coefficient should be high. So we have to choose high lift coefficient aerofoils or high lift coefficient wing condition. This is aerofoil condition. Here we are saying that this induced drag coefficient is indirectly proportional to aspect ratio. It means that aspect ratio is B square by S. So it means that CDI is directly proportional to wing surface area, indirectly proportional to wing span area. It means if the surface area increases, induced drag coefficient will increase. Whereas the wing span increases, induced drag coefficient will reduce. This is the inference we are getting from the induced drag coefficient calculation. Right? Thank you. We'll see the next lesson.